What do you see are some of the major developments happening with respect to data centers in Singapore and then at large APAC?
I see this region having great potential to actually accelerate the adoption of such an advanced cooling solution, right? Maybe even compared to traditional data center hubs like that in US or Europe. I think one of the key reasons, which is quite interesting, is actually...
Today's guest is Dr. Poh Seng, Head of Mechanical Engineering at the National University of Singapore and Executive Director of the Energy Studies Institute. He's a leading expert in sustainable data center cooling, shaping how tomorrow's digital infrastructure is built.
Let's talk a little bit about liquid cooling technologies and how far we can push that.
Now we're already seeing the direct-to-chip cooling involving the use of cold plates which are integrated into your server hardware, as well as the use of immersion cooling which involve dipping the IT equipment into the tank that is filled with dielectric fluid.
I want to take this opportunity to ask you about your own research.
Research-wise, we focus a lot on the design, on the realization of high-performance cold plates and heat sinks. Instead of conventional techniques that involve different parts which you have to join them, which is not 100% leak-proof, leveraging on additive manufacturing whereby we're able to print the entire cold plate as one unibody, thereby eliminating the possibility of leakage. The data center industry, Singapore is no longer able to compete in terms of raw capacity simply because of our land constraint, renewable challenge.
You also mentioned the land constraints in Singapore. So if you wanted to create 24/7 CFE type data centers or manufacturing for that matter, what might be a good strategy given that you want to collaborate with your neighbors?
I think finding the win-win model certainly is very important. So I think what we need to do is really to figure out
Hello everyone, welcome to FutureScaleX's Built to Scale. Today we're pleased to have join us Dr. Poh Seng, Professor and Department Head of Mechanical Engineering at the National University of Singapore and Executive Director of the Energy Studies Institute, to talk to us today about energy and data centers and issues in thermal management. So welcome, Dr. Lee.
Thanks for having me.
Yeah, no, please. Please tell us about yourself, your various roles, and some of your research interest areas.
So my work sits at the intersection of thermal science, data center engineering, and energy policy. So at NUS Mechanical Engineering, my research group advances single and two-phase direct-to-chip and immersion cooling tailored for hot and humid climates like that experience here in the tropics in Singapore, as well as various micro structures that actually serves to enhance heat transfer but reducing the pressure drop penalty. Yeah, but we are actually extending this into data center engineering, right? Because I think it's not good enough to just demonstrate the performance in a lab-based setting, which usually differ significantly from real-world deployment. So we've actually taken a lot of efforts to actually translate or to further develop technology, right? The going out of the lab into for example, the testbed environment. And actually related to that, right, we are also building an ecosystem where we bring together various industry, the stakeholders as relevant government agency. Because sometimes it's not just the technology, right? It's actually the associated business model. It can be the things pertaining to the policies and regulations that needs to be tweaked, right? So as to facilitate accelerated adoptions of various new and innovative data center solutions. Yeah, so we're actually trying to move up the length scale, right? So from micro scale, which is a more the thermal science domain, into data center engineering, which is more of a real world environment, and into ecosystem, right, which is really more involving the industry as well as government's stakeholders.
Well, it's fantastic. I mean, I love the idea of policy and ecosystem building and partnerships. And of course, you mentioned bringing new types of technologies into the data center, but also you mentioned the extensibility into general thermal management. So we'll dive into some of these issues today. So let's start off more generally. AI and data centers are all the rage today. Let's start with some general commentary. And what do you see are some of the major developments happening with respect to data centers in Singapore and then at large APAC?
I think for the longest time, the data center, the industry in this part of the world, best kind of following to what developments in the States, in Europe, or in the places like Japan or even China. But because of demand for the AI and the associated infrastructure, right? So we're actually seeing very interesting juncture in history where I think data centers in this part of the world can take leadership position. I think that one of the key reasons, which is quite interesting, is actually our punishing climatic condition, right? Because when in the old days, the is actually nowhere near the 10, 20 kilowatts, right? So obviously you can safely go back to air cooling, right? Obviously, even for air cooling, there are various forms, right? For example, including the use of containment, the use of adiabatic coolers or heat rejection system. But with high workloads, right, you are actually handling very much a higher heat loads and density, right? But again, if you go back to temperate climate because of the favorable outdoor condition, especially during the winter seasons, you can still, to a certain extent, go back to the tried and tested the air cooling. But here in the tropics, right, because of the punishing outdoor condition, high ambient temperature coupled with high humidity, right, we really don't have much options, right, other than advanced or high performance cooling solutions like liquid cooling, right, direct to chip immersion cooling. So in fact, I see this region having the great potential, right, to actually accelerate the adoption of such an advanced cooling solution, right? Maybe even compared to places, traditional data center hubs like that in US or Europe. While it's challenges, there are various challenges, but I think all these challenges actually also leads to very interesting opportunities for the region.
Yeah. So the cooling part is very interesting because we've seen the evolution of the needs for energy for cooling running from 30%, maybe going down to 10%. But that's in the US, the EU, and the Nordics. So you mentioned the hot and humid temperature area of APAC. So what does it take to run a data center competitively in APAC, given considerations like PUE, WE, power and water utilization efficiencies? And the fact that we need to run these data centers hotter, right? So what do you see happening in this space in terms of innovation and technologies?
I think if we are looking at the just technology versus technology, right? So implementing liquid cooling in the temperate climate versus implementing the liquid cooling in the tropics, the PUE that you're getting here, right, even with liquid cooling, is going to be actually higher simply because of the higher outdoor temperatures and humidity, right? But if we were to really take a system approach, right, and not just looking at, for example, cooling in silo, but the cooling in the relations to other possible, for example, waste heat end use, which again traditionally is actually challenging for this part of the world, right? Because of our climates, we require the cooling rather than space heating, right? But then if we were to solve the advance this idea of circularity industry symbiosis, right? I think that's where data center in APAC, in Southeast Asia, right, has the potential to really manage not just the energy footprint, but also the carbon footprint in a more effective fashion. But it really requires a collaborative approach, breaking down silos and getting the different stakeholders to come together, not just operators, not just vendors, but also academia and the government agency, right, to come together so that you can have this collaborative and this system of thinking, right, so as to sort of realize the most sustainable data center possible.
Well, in 2024, I think Singapore released its green data center roadmap, right? And at the time, there was about 70 cloud enterprise and colos in Singapore, about 1.4 gigawatts. How big does Singapore anticipate data centers becoming in Singapore, and maybe with your nearest neighbors? And we'll touch on your nearest neighbors later in the talk, of course.
And so I think the latest figures that was actually released a couple of months is Singapore's data center capacity is now about 1.7 gigawatts, right? But if you look at Malaysia, right? Malaysia, I think now it's already about close to that, right? It's probably about 1.5 or 1.7, close to the same level. But the projection is actually by next year, right? They will reach 2.7. And I was actually going through one of a recent market report, even for Thailand, right? So they having committed capacity up to 2.5 gigawatt. So Singapore is no longer able to compete in terms of raw capacity. I think simply because of our land constraints, right? Our the renewable the challenge situations, right? So if we want to meet the net zero commitment, certainly Singapore government can't actually allow uncontrolled expansion of the data center industry, which obviously is an energy guzzler. We need to do is really to figure out what is the sweet spots for Singapore, right? So I don't think it makes sense for Singapore to be competing in terms of, for example, AI training types of data centers. But if you were to focus on, for example, AI inferencing, which you can make use of, obviously not just the more efficient cooling and power solutions, access to the green energy, but also energy efficient IT, right? Coupled with green computing. I think that's where I think Singapore will have the best chances of managing the industry, energy and carbon footprint and allowing Singapore to meet its net zero, the 2050 ambition.
Okay. I mean, it's interesting because what you're talking about is an innovation ecosystem that's intentional, right? And given the constraints, rather than seeing them as constraints, but rather opportunities for innovation. So, as you mentioned in the Green DC plan, there is this idea of carbon efficient software design and integration. So, I don't know, it may be early days, but how does that come together, I guess?
In fact, just a few weeks ago, Singapore actually launched a new standards, right, on the energy efficient IT, and it was actually mentioned in the standard that if you to adopt energy efficient IT, right, that can actually quite readily translate to 30% saving in terms of your energy consumption, right? Then obviously the associated water consumption and carbon footprint. But then again, it really needs a collaborative approach. So I use an example, right? For colo operators, typically they don't get involved in terms of what kind of IT that their tenants bring into their white space, right? And it's because of this separation of responsibility, that's where a lot of synergy are not often realized, right? But now with this, for example, government taking an active approach, coming up with new standards, so I hope it will actually get dialogue going, right, between operators and tenants, so that operators can also come in at a very early stage to advise what would be the kind of power cooling that will actually support the IT needs, right, rather than an afterthought. Oftentimes, you get the requirements from your tenants, right, after they have actually selected their IT configurations, right? Then obviously you have less freedom, less flexibility in terms of selecting the most efficient or more sustainable the power and cooling solution. But if let's suppose this dialogue was to start at an early stage, right, it's almost like a co-design, right, whereby the IT teams from the client actually talk to the facilities from the colo the site, so that they can collectively figure out so what would be the combination of IT power and cooling, right, that would actually allow the entire operations to be the most sustainable possible. Yeah, so I think that there's a need to break down silos, and I see Singapore government actually taking the leadership, right, starting with establishment of new standards, right? So I think I mentioned the energy efficient IT. Then about 1.5, 2 years ago, we actually have a tropical data center standards that recommends operators setting their supply air temperature to 26 degrees Celsius and above, right? Which can translate to again signal saving in terms of your cooling energy consumption. Right, then I'm actually now leading a working group to develop the standards on liquid cooling. So I think such initiative, right, standard coupled with, like, for example, co-innovation platform, coupled with probably government grants, incentive, I think all this is going to sort of nudge the industry to move towards the right directions. Yeah, but I think that it really needs to be a highly collaborative and highly intentional exercise.
Right. And you had mentioned, Dr. Lee, the movement from LLMs to inference models, and of course, billions of dollars are being invested in new types of chips and everything, which actually should decrease power consumption at least at the rack level, chip and rack level. But still, I mean, given the trends today, and this is a good segue into cooling technologies, as people talk about moving from, let's say, 10 or 15 years ago, 2 or 5 kilowatts per rack to 20 kilowatts to some people are talking about 600 kilowatts all the way up to 1 megawatt per rack in terms of, instantaneous demand. How does cooling technologies specifically deal with this? And you mentioned air cooling, but let's talk a little bit about liquid cooling technologies and how far we can push that.
I think now we're already seeing, for example, direct-to-chip the liquid cooling involving the use of the cold plates, which are integrated into your server hardware, as well as the use of immersion cooling, which involve dipping the IT equipment into the tank that is filled with dielectric fluids. So I think there will be a lot of take up in terms of this solution, but I think at the different pace, right? For example, immersion cooling will probably take a while to sort of scale up, right? Because there are certain issues that needs to be addressed before they can become one of the mainstream option. But at least for direct to chip, I think we're already seeing a accelerated pickup. So I think that just to me is just a phase one, right? But to your point, right? So as TDP thermal design power, as rack density go through the roof, right? We talk about 600 kilowatt, 1 mega rack. I think then it really requires the addressing the thermal issues at the different length scale, right? I think we spoke about at the chip level, right? So you can actually look into embedding microfluidic channels within the silicon substrates, right? Or you can even change the substrate from silicon to another material that can be, for example, tolerate higher temperature, right? So that your junction temperature can be set higher, right? But you can certainly look into embedding your microfluidic channels into your substrate. You can also look into unifying the heat spreader together with cold plate. Currently, your heat spreaders is actually separate from cold plates. Then you have to make use of a thermal interface material, which oftentimes is the bottleneck for effective thermal management, right? So it really needs to, for example, start addressing it at the chip level. But I think beyond the chip level, you have to look at, for example, at the rack level, at the hall level, right? So if we again go with conventional the chilled water piping system, right? To handle 600 kilowatt or 1 megawatt rack density, your piping size will be huge, right? So there will be a lot of infrastructural implication, right? In terms of the much higher headroom or the much deeper the raised floor, right? You also have implication in terms of the loading, right? I think that's why, for example, we may have to bring that some of the concept that people may have kind of root out, right? For example, if you use refrigerant-based, DX-based systems, right? Then you can greatly manage the piping size, right? Then obviously reducing the infrastructure, the cost, things like that. But also the heat rejection, right? Not to forget, oftentimes people only talk about what happened inside the white series. But what about actually the heat rejection, right? If we continue to sort of generate a lot of heat and actually at the end of exercise, continue to just offload or reject this to the environment, that's going to actually compromise livability, is going to exacerbate urban heat island effect, right? So can we actually look into, for example, co-locating data centers, right? With end use for low-grade heat, right? For example, maybe the co-locating data centers, who knows, maybe with a residential precinct, right? Whereby they need hot water for hot shower, for cleaning, for the laundry, right? I can co-locate, for example, with a laundry factory, with F&Bs that actually requires low-grade heating, or even with industry, right? But using the low-grade waste heat as preheating. But I think it really needs to adopt again a system approach, right? For example, even as early as the master planning level, right? The government agencies, right, have to come in and be very intentional, right? Where you locate the data centers, right? So that, for example, there's possibly for the good end use of waste heat, right? But also, for example, having access to green electrons, right? For example, here in Singapore, the authorities are talking about locating new data centers on Jurong Island, which traditionally is a petrochemical hub, right? The last thing the operators will think of is setting up or siting their data center, but it's a place that the government have earmarked to have access to various green energy sources, right? From green hydrogen, green ammonia, biomethane, bio-LNG, right? So all these are actually the solution that can help the data center industry to be decarbonized. But again, it needs to be very intentional, right? And at a very early stage.
And are you patterning some of these off the Europeans? Because my opinion is that they're ahead of the US in terms of thinking about this kind of ecosystems, heat as a service, if you will. Any thoughts on how Singapore might kind of leapfrog towards that?
No, I think that's why I think the location like Jurong Island becomes very interesting, because on Jurong Islands you have various industry that actually requires heating, right? For example, they are already having, I think if I remember correctly, it's actually like steam as a service, right? Instead of for example, each the industry or companies having their on-site boilers, right? So there's actually a centralized facilities that actually produce steam, right? That can be actually sent through piping. It's almost like a district heating network, right? But in this case, actually sending steam. So you can actually think about embedding data centers within such district heating systems, right? But also interestingly, it's actually, for example, Jurong Island, actually they have the LNG terminal, right? Which they have to gasify the natural gas, right, before it can be sent into the gas pipeline. So in the process, it actually releases very precious cold energy. So what about also, right, embedding data center within the district cooling that takes advantage of such free cooling energy resources? That's what, again, I think there's a lot of potential. So, but it needs to be very collaborative. It needs to be very intentional.
Okay, fantastic. Well, we'll come back to this in terms of business models later, but I want to take this opportunity to ask you about your own research, and perhaps not surprisingly, I think you've launched a startup. So tell us a little bit about that technology, how it might impact data centers, and especially with respect to, as you were talking about, chip design and manufacturing of chips going forward.
I'm actually very passionate about translating the research outcome into deployable solutions. So that's why I think since the 10, I think in fact more than 10 years ago, I think shortly after I joined the National University of Singapore, I founded my first startup, right? So which was on thermal management of EV buses for the battery. But it didn't quite work out. I think we were probably a bit early, because probably like 15 years ago, we are talking about doing the liquid cooling, right, for battery thermal management. Yeah, so that first venture didn't work out. And I think fast forward about 10 years, right, that's when I actually created the Coolers DC, my current startup, right? But I think obviously moving from a lab settings into a startup environment, into commercial deployment, there's quite a steep learning curve. Yeah, but I think that we are actually very fortunate that over the years, we actually have opportunities to interact with various industry players, right? And I think it's through this regular dialogues, or regular exchange of ideas, that I think we are able to sort of fast track some of the development. So we're actually starting to address various data center liquid cooling project. But maybe to sort of elaborate a bit more, right? So as you rightly pointed out, right, research wise, we focus a lot on the design, on the realization of high performance cold plates and heat sinks, right? For example, various types of fin structures that modulate or reduce the thermal boundary layer thickness in order to improve the performance, right, or reduces the thermal resistance, right? But then when you talk about actual implementation, with for example, your GPU chips price going through the roof, right? So that easily will be your single biggest ticket item. So how do we actually protect our investment? That actually led us to actually look at the manufacturing technique, right? Instead of conventional techniques that if involve different parts which you have to join them, right? Because you want to confine the liquid to flow within your cold plates or whatnot, right? But because of these different parts, then with the joining process, which is not 100% leak proof, right? There's still this the risk of leakage. So that actually prompted us to look at the manufacturing technology as well, right? For example, leveraging on additive manufacturing, whereby we're able to print the entire cold plate, right, from the base, the micro channels, the fins, the top covers, the connector, as one unibody, thereby eliminating the possibility of leakage. Yeah. So I think it's actually such a startup journey that kind of actually prompted us to look at some of the issues that, to be honest, a lot of researchers tradition don't spend too much attention, right? Because a thermal scientist usually will just focus on the performance of your heat sink cold plates, fin structure, right? You don't spend as much time looking that deeply into manufacturing technology. But because of the commercialization effort, that actually forces us to really take a holistic the perspective, right? It's not just about the performance, but it's also how do we ensure how do we address some of the implementation concerns, right? And again, cold plate is just one aspect of liquid cooling. So we also venture into designing the whole liquid cooling infrastructure, because without the supporting liquid infrastructure, there's no way that you can bring in the GPU servers, your high power, the racks. And so that's why I think this journey to me has been very enlightening, right? So it actually allows me to go from the micro length scale all the way to the real world environment, and even actually the regular dialogues that we are having with industry players and the government stakeholders.
Well, I love the circularity argument, because now we're talking about recirculating the heat, and we're moving away from evaporative cooling. And now we're actually talking about redesigning the chip itself, because up until now, cooling has sort of been a bolt-on solution after the fact, right? But now you're saying that we have to redesign from the ground up, including the software, including the business model and the ecosystem that data centers find themselves in, right? So that's very exciting. And there's been a lot of money thrown into these new chip designers, and I think including one in South Korea, Furiosa AI. So, I mean, in Singapore, are there similar initiatives, and are you thinking about partnering with any of them in terms of helping them think about cooler chips?
Mm, mm. So I think for Singapore, given that we are a city state, I think we need to be quite strategic in terms of where we make our bets, right? So I think in terms of chips development or design of the next generation chip, I think that's probably not a space that Singapore should be playing, but I think Singapore should be focusing on the chip packaging, right?
Okay.
You can, for example, with the restart companies or even NVIDIA, right, on the chips, but this has to package, right, in order, for example, to effectively draw out the heat, right, so that you can achieve the spec performance. You're able to sort of manage the power draw, things like that. So I think that's where I think Singapore government is actually placing its bet, right, on the packaging level. Right, then obviously with appropriate packaging, the chip can then be used for example, different application, like be it the LLM inferencing, whatnot. So I think that would be something that Singapore should be focusing on. And then I think for my startup, obviously, I think along the same line, we can certainly in fact we would very much want to work with, for example, the chip manufacturers. Yeah, so that we can actually add values and actually allow the best possible performance and the most sustainable operations to be achieved.
Okay. Well, let me ask you a question about general thermal management. So, moving from, say, microfluidics at the chip level, what are some of the things that you've learned that could actually have application to, say, operations on Jurong Island, to large materials and chemical manufacturers?
I think definitely there are actually the interesting similarity, right? Just to use an example, right? So the district cooling, right? Singapore have actually over time been sort of scaling up district cooling. And district cooling typically again is still sort of supplying to your AHU, right? Which kind of do the liquid to air heat exchange, right? Because in a built environment settings, right, the heat density is actually less intense, right, compared to a data center environment. But then if you look at, for example, how the centralized district cooling plant is actually distributing the liquid flows to the different buildings, right, to basically the different heat loads, right? How do you actually ensure water balancing, right? How do you actually ensure right provisioning of the flow rate? Because every building actually have different heat loads, right? So it's actually in fact very similar to the data center liquid cooling infrastructure, right? You have a centralized CDU that is actually delivering flow rates to your different racks, And these different racks are having somewhat different IT the configuration, then even the dynamic workload can change quite rapidly over time, especially when you're handling like bursty AI workload. So I think there are actually some similarity, but obviously there are differences, right? But I think some of the learning points that, for example, Singapore or even other countries have for other types of application, with some adaptation, it can certainly be relevant to data center. And I think in similar notes, right, those learning points that we gather from the liquid cooling the data center can also be applied to other the scenarios. So to give you a specific example, so we started a discussion with one of the local hospital, right? So they are actually very concerned about the energy drawn when it comes to air conditioning systems, right? Especially in the hospitals, public hospitals, there are different types of watts, right? For example, Watt C is designed to be naturally ventilated, so meaning without air conditioning. But that as the weather, or rather the heat wave becomes more frequent, right? Then certainly there's also a need, right, to ensure the proper thermal comfort is maintained in such naturally ventilated watts. So that's why they're actually looking at what would be some of the low-cost way of doing air conditioning, not the traditional way. And that's where we thought actually, why can't we actually adapt what we're doing in the white space, right? In terms of delivering chill water to the different racks. But now the rack is basically the bed, right? So how do you actually write provision? Because again, thermal comfort is actually very subjective, right? Certain patients may achieve the expect a higher flow rate, lower temperature, right? Versus another patient that actually is perfectly fine without the so-called air conditioning. So we are actually adapting some of the concept that we have learned from data centers, liquid cooling, the deployment, right? And adapting it for a hospital setting. Obviously, I think along the way, there will be unique issues that we need to address. But I think being able to port over a big part of the learning points from data center, I think certainly helps to shorten the entire learning curve. But I think we need to be very open-minded, be very adaptive. I think that's where I think a lot of wonderful synergy can be found in adjacent applications.
Right. Well, we have a long-standing interest in heat pumps, heat exchangers, and of course, cooling and chilling here at FSX. So I'm very fascinated by your comments there. But we can't really talk about cooling without at least involving some discussion about phase change materials. Because typically, when people talk about cooling, we think about liquids. But maybe you have some thoughts that you could share with us about what you see as the more promising areas for phase change materials.
Phase change material is actually interesting because it's basically thermal batteries, right? The phase change thermal battery. Obviously, you can still have your more regular single phase, like the chill water based thermal energy storage, the tank or systems. But you can also have PCM. But PCM also different types. Right? Ice storage is considered a PCM, right? So it's actually a liquid to ice conversion, right? Liquid to the solid phase conversion. But it can also be other types of PCM materials, which then it can have the phase change at, for example, different or lower temperatures. So I think phase change or PCM types of thermal storage solution actually have a role to play, especially I think for AI data centers, right? So again, I think going back to our previous discussion on bursty AI workload, right? If we were to design your cooling system to just handle the short instances of peak AI workload, obviously you have to oversize your chiller, your CDU, everything, right? Then obviously the supporting infrastructure, your piping systems, right? But if you were to, for example, embed PCM, right? For example, potentially even down to the rack level, or you can actually embed it inside a cold plate, right? We can create pockets within your cold plates, which you inject the PCM. So during the bursty instances, right? The PCM can basically lock in the heat, right? Then actually releases it later on when the AI workload actually comes down. Right? So it can be nested at different level, right? It can be nested at the chip or the cold plate level. It can nested at the rack level. It can also be nested at the facilities level, right? Where you see obviously the gigantic size thermal energy storage system. So I think the PCM I see a big role that that it can play, right? Going forward, especially for the AI types of deployment.
Well, I love the idea of this burst capabilities, and as you mentioned, having a reservoir of capacity, because what we're hearing and when we talk to people is that given SLAs for data centers, the back end capacity needs to actually correspondingly grow because of, let's say, outages, climate change,
Yes.
etc. And even to the extent that you actually have to have backup that's equivalent to the actual output power during normal operations for, say, hours to days, right? And so
Yes.
this idea of phase change materials as thermal batteries is really quite interesting. Um,
Um,
but let me shift a little bit because as head of the Energy Institute, many people might not know too much about it, especially our European and U.S. clients. But what are some of the key research fronts for ESI?
At the Energy Studies Institute is energy policy, the think tank, primarily funded by our Ministry of Trade and Industry. Right? So we actually look at the various energy the policy questions, right? I think one of our flagship program is the energy system modeling, right? Because Singapore, since a few years ago, have made our net zero commitment, right, which is 2050, right? Then there's actually the LEDs, whatnot. So in order to reach that target, right, Singapore is actually very meticulous, right, in terms of what will be the energy, the options, what will be energy solutions, right, that we need to sort of deploy, that we need to integrate, right, from now till 2050 in order to reach a net zero by then. So energy system modeling then becomes very important, right? For example, you want to know, for example, should green hydrogen becomes commercially available by 2035, right? Then at what point should Singapore be putting in place the necessary infrastructure, right? For example, the storage, right? The distribution network, right? Then what are some of the things that you need to do in terms of, for example, the GenCo, right? Maybe the CCGT needs to the now starting with taking up to 30% hydrogen, but maybe by 2030, right, the new CCGT had to go up to 50%, in time to come 70%, right? So the more macro level of planning actually requires such a sophisticated energy system modeling. So with ESI have been doing that for the past decade or so, right? So in fact, we developed a SG times model, right, that actually allows us to look at the cup trajectory, the cup pathway. But we are also looking at, for example, issues pertaining to security of supply, right? Singapore being a city state, right, with its limited land mass, our renewable energy are all imported, or rather, all our energy sources are imported, right? So how do we actually ensure the security of supply, especially with the recent geopolitics issues that are happening the past couple of years? So we are looking at, for example, one specific option, which is the ASEAN Power Grid, right? Importing low carbon electricity from across the region, and maybe even as far as from Australia, right? So this again requires the modeling, right? For example, how do you ensure that such a ASEAN Power Grid is going to be a win-win? Obviously, it will be a win to Singapore, right? Because since we are very short of energy sources, so we will always have to import energy from around the world. But what about our ASEAN neighbors, right? So what is the takeaway from them, right? So obviously the business model, the pricing, the ruling charges, all this has to make sense to our neighbors as well, right? Because they also have their net zero commitment to fulfill, right? So we're actually looking at, like, for example, the APG types of modeling, but we are also looking at, for example, strategies of other key economies, right? Again, a lot of learning points from around the world, right? For example, what the state is doing, what China has been doing, what is planning to do for the next 20, 30 years.
Sure.
EU, right? CBAM, right? How it's going to impact trade,
Yep.
right? Then with the recent the tariff things that we're also looking at carbon pricing, climate financing. So actually we're actually looking at a array of energy policy related issues, right? That the Singapore needs to sort of address, right? From now till 2050.
Well, I know as director of the institute, you're probably talking to counterparts both in government, academia, maybe in the business community as well. And you mentioned your nearest neighbors, and you mentioned the fact that Singapore has just released its own data center standards. What are some of the things that you're discussing with your counterparts in the ASEAN region that could actually help the region itself kind of either compete or catch up or even surpass what's going on in the EU and the US?
Especially for the data centers, I've been actively talking to, for example, the Indonesia the Data Centers Owners Association, IDPRO, right? So to look at, for example, how do you come together to collaborate, right? Because, for example, those the power, cooling, green energy solutions that Singapore is test bedding is going to be very relevant, right, to the operators that are having operation across the Southeast Asia or even the greater tropics and the greater the APEC. But instead of, for example, individual country doing the more or less the same thing, right? Why don't we come together? Certain technology, to be honest, it probably will be easier to be test bedded in the other countries or outside of Singapore. For example, you are talking about the hydrogen-based solution, right? Various types, right? Be it fuel cells or be it the flexible fuel generators coupled with, for example, carbon capture, which then obviously also needs to do the natural question. Are you going to store it? Are you going to utilize it? So some of these things probably will be a lot faster, right, if done outside Singapore, because Singapore actually have our own unique constraint. But if you were to adopt a highly collaborative approach, right, with the learning points from the different technology that we are test bedding with our partners, right, we can share all these findings, learning points, so that collectively we can actually make informed decisions. So I firmly believe that the energy transition, the decarb journey, has to be at all hands on that, and we can no longer operate within our respective silo. Or you have to break down a silo. You have to come together, right? Sometimes, obviously, the necessitating making trade-off, compromises, whatnot. But then I think the whole region then have the best chances of actually meeting our the net zero and the decarb ambitions.
Well, Dr. Lee, you mentioned carbon-free electrons. That's definitely something that's caught the attention of certainly the UN and Google and others. And you mentioned carbon trading. Today, it's basically certificates, right? But it's also sparked a lot of interest in how do you combine fossil fuels with renewables and then maybe eventually phase out the fossil fuels. But you also mentioned the land constraints in Singapore. So if you wanted to create 24/7 CFE type data centers or manufacturing for that matter, what might be a good strategy given that you want to collaborate with your neighbors?
I think finding the win-win model certainly is actually very important, right? So I think it's not just green energy. Even, for example, when it comes to AI data center, right? If we were to create this regional network for the data, right? For example, the LLM, the AI training can be done at places like the Johor Bahru in Malaysia, Batam in Indonesia, and then some of the inferencing, the workload, right, can be done here in Singapore, where there are many startups, right, focusing on various AI-related applications, right? Then I think we have the best possibility of actually effectively managing the carbon emission of the entire region. But obviously, green energy is actually something that is on everybody's mind, right? So when talk about APG, but then when it comes to the actual implementation, right, obviously there will be a lot of bilateral, multilateral agreements, right? But I think importantly is also we have to again be adopting a collaborative approach. It can't be, for example, let's say, okay, Singapore has a demand, so we expect the commercial players will actually just figure out the arrangement. I think sometimes you also need to encourage some of the Singapore LLC, right, the like of Keppel, Sembcorp, to actively go into the region, help the local partners, right, in terms of the technology, knowledge transfer, right, so that they also win in the process, right, move up the technology, the ladder chain, things like that. So I think again is has to be very intentional, right? And I think it has to be the comprehensive, right? Can't be, for example, just say, okay, simply creating the demand. I think we also need to help our neighbors win, right? We need to help them move up the technology ladder chain. We need to help them also grow the local industry, right? For example, besides simply exporting the green electrons, right? Can we also look into setting up the regional manufacturing base, right? For example, Singapore have actually signed the special economic zone with both Malaysia and Indonesia, right? So can we actually encourage Singapore enterprises, right, to set up regional manufacturing bases in these places, right? I think this makes us, besides helping our neighbors, I think it also allows us better control of scope 3 emission. Yeah. So like it need to really be very intentional, be very collaborative, and actually really come together. I think that's how we are able to best
Right. Well, it's interesting
meet our
because
target.
you're talking about a very expanded economic zone, right? That encompasses your nearest neighbors, where you can locate a company, let's say in
Yeah.
Malaysia, but maybe use the data center capabilities back in
Yes.
Singapore and to manufacture, et cetera. And now you mentioned a lot of different things, and carbon capture and carbon management is kind of near and dear to FSX's heart here. But one of the things that we see as a challenge is transport, right, across the region, especially in ASEAN. And we're increasingly looking at the Northern Lights project as kind of a model for the rest of the world. I mean, is that something that you guys are thinking about, or is there a different model that's going to be required to kind of capture carbon from all of these different offshore and onshore assets and then pipe them down to, say, a place like Australia?
I think we have again starting in our neighborhood. So I think that we have been actively discussing with Indonesian government. In fact, I think they have actually signed one of the first stage agreement, right, to look into storing the carbon in Indonesia. Then here in Singapore, we have key players, industry players like ExxonMobil and Shell coming together to set up a S hub, right? Which is actually, in fact, interestingly on Jurong Island. I think that's also the reason why from the phase 2 of my Sustainable Tropical Data Center Test Initiative, we very much want it to be nested on Jurong Island, right? So that again is you take advantage of various other adjacent initiative, right? The S Hub, which is more on the carbon capture and storage, but there's also A-Star initiative that focuses on the carbon capture and utilization, right? Then obviously then integration with renewables, then those sustainable power cooling solutions that we are going to be executing. But if all these different pieces come together to get all the stars aligned, I think that's where I think the industry have the best chances of actually deeply decarbonizing. But again, you see, it's again not just benefiting the industry in Singapore. I think really we need to set aside and minimally across the region. And in fact, I think it makes a lot of sense, right, for us to be serving the APEC region.
Well, hey, one last question, Dr. Lee. Maybe potential for you to make a pitch. So when I talk to data centers and manufacturers, they'll say, okay, I'm focused in the US, I'm focused in Europe, I might have operations back and forth. I don't have a footprint in APAC. Should I move to Singapore? Should I put something there? If I was a data center operator, why should I consider putting a data center or manufacturing operation in Singapore?
Now, I think while Singapore can no longer be data center hub in terms of raw capacity, but I think Singapore can be the hub for sustainable data centers technology development. So I think with the kind of investment that the government is putting in terms of talent development, the kind of resources that they're putting in to encourage academia researchers to work with industry players, the kind of platforms, co-innovation platform they are putting in place, I think Singapore remains relevant. Yeah, but obviously, as mentioned, right, we should focus on the value adding part, right? It shouldn't be more of the same thing.
All right. So, hey, Dr. Lee, it's been a delight to speak with you. Thank you very much. And for those of you out there, if you'd like to talk more with Dr. Lee or with us, please feel free to contact the National University of Singapore and the Institute for Energy Studies, or feel free to come to our website and click on contact at futurescalex.com. Thank you very much, Dr. Lee.
Thank you.